Welcome students. In today's class, we will discuss the energy and power signals. So today's topic of discussion is energy and power signals. So what is mean by energy signal? So energy signal is a signal which has finite energy. So a signal is said to be an energy signal if it has a finite energy, which means the energy of a signal is a finite quantity and it is less than infinity. Similarly, a power signal is a one which has a definite power or a finite power. So if signal has finite power, then it is said to be a power signal. So power of a signal should be finite. So a signal is said to be an energy signal if it has a finite energy, and a signal is said to be a power signal if it has a finite power. Now we have studied two different types of signals. One is a continuous time signal and another is a discrete time signal. So we'll discuss what is the equation for computing energy in case of continuous time signal and in case of discrete time signal. So in case of continuous time signal, the energy is given by integration from minus infinity to plus infinity x square t dt. This is the formula with the help of which we can calculate the energy of a signal. Exactly like this, in discrete time signal, the integration becomes summation and therefore the energy is given by x square n going from minus infinity up to plus infinity. So this is the formula for energy in discrete domain. Okay, so if we go for power, then the equation for power is given by P is equal to integration x square t dt, and limits are from, let's say, minus t to plus t. Okay, and we are dividing this by a base, that is 1 by 2t, and we are taking a limiting case as limit t tending to infinity. So here you observe the limits of integrations are from minus t to plus t, and hence we are dividing this total integration by a base or a duration called as the 2t. Exactly like this, we can modify this formula a little bit by changing the limits of integration. Let's put limit t is equal to infinity here as it is, but the limits of integration will change. Now in this case, suppose if I take limits of integration, let's say from minus t by 2 to plus t by 2, okay, then the base will be t. So I am here in this case, now we'll divide it by 1 by t, and x square t dt will be the internal signal as it is. So this is the way how we can write the equation of a power in case of continuous time signal. In case of discrete, power is given by summation n going from, let's say, minus n to plus n x square n. This is as it is, but here now you observe the base time is given from minus n to plus n, including this 0. So the length of this entire span will be 2n plus this 0th sample, which is nothing but 2n plus 1. So therefore we divide this by base 1 2n plus 1, and we take a limiting case, limit capital N tending to infinity. So with the help of this equation, we are able to calculate the power of a signal. So these are the equations which we are going to use while computing the energy and power of a signal. We have to remember that if a signal is a complex exponential, then in that case, the power equation will be changing slightly. Instead of simply squaring x as x square t, will take mod of it, because complex signal may have a positive as well as negative value, and then we put the limits of integration. Rest all the things are same. So we have to remember this special condition for complex exponential signal, such that when the signal is complex exponential, we have to take the mod value of a signal. Okay, so after completing these basic fundamentals, let us take examples. So example 1, let us take xt is equal to e raised to minus at ut. So here we know that e raised to minus at is a decaying signal, and u of t is a one-sided, that is right-sided signal, and we want to test whether this signal is an energy signal or a power signal. This is a problem given to us. We have to determine whether this given signal is the energy signal or power signal. What is the solution? So let us write the equation for energy. So energy is given by integration from minus infinity to plus infinity x square t dt. This is our basic equation for computing energy. So here if we put the limits of integration, u of t is a signal which exists only to the right, so it is equal to 1 for t greater than or is equal to 0, and it is 0 for t less than 0. Therefore it is a right-sided sequence, and hence we take limit as 0 to infinity. X square t will be e raised to minus at and whole square, okay, dt. So after further simplification we will get integration 0 to infinity e raised to minus 2at dt. So if we simplify this integration, we get energy is equal to 1 upon 2a with negative sign, okay, because we are integrating with respect to t, and e raised to minus 2at, and we are putting limits from 0 to infinity. Now you check, if we put limit t is equal to plus infinity here, then e raised to minus infinity will be 0, and e raised to 0 will be equal to 1. E raised to 0 will be equal to 1, and therefore we will get 1 by 2a as it is. E raised to minus infinity is 0 minus this e raised to 0 is 1. Okay, so this minus become plus, and therefore answer will be 1 by 2a. So this is the energy of this signal. Energy is measured in joules, therefore we'll write the unit as a J. So this is the energy of this signal. So let us test what shall be its power. So I want to give you some remarks by finding the power of this signal. So we know that the signal xt given to us is e to the power minus at ut, and we are interested in finding the power. So power is given by limit t tending to infinity 1 over 2t integration limits from minus t to plus t x square t dt. This is our basic formula. And since I told you in the previous slide that u of t exists only to the right side, the limits will be changing from 0 to t, and limit t will be tending to infinity. So if it is so, then you observe this part we have already calculated as a energy, and this energy is coming out to be finite quantity. This energy is a finite quantity. So finite quantity divided by t, and where t is, I am putting this limit as t tending to infinity. So if I put this t as infinity, then finite divided by infinite will be 1 by infinite, which is equal to 0. And therefore the power of this signal is 0. So this is the important conclusion that we can draw from this example, that if a signal is energy, if a signal is energy signal, then its power P is equal to 0. So this is the important conclusion we can draw from this discussion. Okay, so continuing with the same slides, we'll take another example. Here in this case we'll take some different signals, so to understand how to calculate energy and power. So let's say this is my time base, and I have a signal, let's say like this, which starts from, let's say, minus tau by 2 to, let's say, tau by 2, and this is what xt given to us, and we have to check xt is energy or power. So we have to check this. So how we'll proceed? Again, the same steps we have to follow. So solution, will first of all calculate the energy. So energy will be given by integration from minus infinity to plus infinity x square t dt. Okay, so here limit minus infinity to plus infinity is there in the integration formula, but from minus infinity till this point the signal is 0, and similarly from this point onwards also the signal value is 0. So limits of integrations are only existing from minus tau by 2 to plus tau by 2, and the value of, let's say, this signal will be a. So this is a square dt. So a square is constant, you can take it outside. So energy will be equal to a square, and integration of 1 with respect to dt will be t, and I am putting limits from minus tau by 2 to plus tau by 2. If I put these limits, then my answer will be 2 tau divided by 2, which is nothing but tau. So this is the energy of signal measured in joules. Okay, so again in this case we have received the finite energy. Let us try to find out the power of this signal. So power is given by limit t tending to infinity 1 by 2t integral minus t to plus t x square t dt. This is our standard formula. So again putting the limits, limit t tending to infinity, 1 over 2t. Now you observe limits here are again minus tau by 2 to plus tau by 2. This is a square and this is dt, and we have already computed this integration in the previous slide. And we know that it is a finite quantity. And again the finite quantity divided by t, and t tending to infinity, which gives us 1 by infinity, which is nothing but 0. So power in this case also equal to 0. So in this case also the power of a signal is 0. Let us take a third example. This is very interesting example. Let's take unit step. So I know that unit step is something like this. We have studied it. So it has amplitude equal to 1. Okay, and we denote this by u of t. And we want to test whether this is energy or power signal. We want to test. Okay, we all know that u of t is defined mathematically as it is equal to 1 for t greater than or is equal to 0, and it is 0 for t less than 0. This is a mathematical definition of a unit step. So we want to test whether this signal is energy signal or power signal. So let us move ahead. So energy of signal u of t is calculated by this way: minus infinity to infinity x square t dt. Now here xt is nothing but equal to ut, and ut exists only from t greater than or is equal to 0. It is equal to 1. Okay, this is 1, and for t less than 0 it is 0. So therefore my limits of integrations will be from 0 to infinity 1. Okay, amplitude is 1 dt. Okay, and after simplification I will get t, and I am putting limits 0 to infinity, so energy is coming out to be infinite. So energy of this unit step signal is infinite. Let us check what shall be its power. So power is given by, let me check different color, 1 over 2t integral minus t to plus t, okay, x square t dt. This is our formula. Here limiting case is there, obviously, limit t tending to infinity. So again xt is equal to ut, because we are continuing the same example, and ut is equal to 1. We know for t greater than or is equal to 0, and it is 0 for t less than 0. Therefore x square t is 1, and limits of integrations are changing from 0 to t. So we are putting limit t tending to infinity 1 by 2t integral from 0 to t 1 square dt. After simplification we will get limit t tending to infinity 1 by 2t. This is 1 square means 1. Limit with integration with respect to dt is a t, and if we substitute upper limit and lower limit, then we will get this as 1 over 2t. Okay, 1 over 2t, and here I am putting t minus 0. So this is t, this t get cancelled, and power is coming out to be equal to 1 by 2, and power is measured in watts. Therefore power of this unit step signal is half watt, and therefore unit step signal is a power signal. So this is a very important conclusion that we have derived, that unit step signal is a power signal. Unit step signal is a power signal. Let us go to the next example, wherein we take xt is equal to, let's take rt. We know that rt is a ramp signal. rt is a ramp signal, and it is defined as rt is equal to t for t greater than or is equal to 0, and it is 0 for t less than 0. And it is shown something like this. It is a straight line passing through origin. So the signal looks like this and it has unit slope. This line has unit slope. So this is R of t. So we want to test whether this signal is an energy signal or power signal. So let us go ahead and test what will happen. Let us test. So energy is given by integration minus infinity to plus infinity x square t dt. Now here xt is equal to rt, xt is equal to rt, which is equal to t for t greater than is equal to 0 and is 0 for t less than 0. So my limits of integrations will be from 0 to infinity x square t, means it is t square. Okay, so t square dt. So if we simplify this integration, we will get t cube divided by 3, and if we substitute the limits, then upper limit will be infinity and lower limit will be 0. So this also gives us energy is equal to infinity. The energy of this signal is infinite. And if we calculate the power, then power is given by limit t tending to infinity. Power is given by limit t tending to infinity 1 by 2t, limits from minus t to plus t, x square t dt. So if we calculate the power of this signal, then it will be limit t tending to infinity 1 over 2t. Again, limit is from 0 to t. This is t square dt. Again, it is t cube. Okay, so limit t tending to infinity 1 by 2t, limit integration of this will be t cube by 3, and I am putting limit as 0 and upper limit is t, and here t tending to infinity, and therefore this answer is also infinity. So you observe this ramp signal is having, so for this is a special case. For ramp, energy is also infinite and power is also infinite, which indicates that this signal is neither this signal is neither energy nor power. So this is the important conclusion that we can draw. So there are few signals which are neither energy nor power. So ramp is an example of such a type of signals. So from this we have drawn very important conclusions, and let me write down those conclusions before concluding my today's lectures. And this is important conclusions. Conclusion number 1, finite duration, finite amplitude signal. So for finite duration, finite amplitude signals, for finite duration, finite amplitude signals, it is always energy. It is always energy, which means energy is finite. They are energy signal. So finite duration and finite amplitude signal, this is very important to know. Amplitude is finite as well as duration is finite. Those signals are always energy signals because energy of those signals is finite. And second important conclusion, infinite duration time signal, infinite duration signal, but decaying amplitude Okay, as we have seen in exponential decaying signal, infinite duration signal, amplitude amplitude decaying. Amplitude is decaying. Such signals are also energy signals. Such signals are also energy signals. And the last important conclusion is that infinite duration, finite amplitude signals. Third conclusion, infinite duration, infinite duration, finite amplitude signal, finite amplitude signal are power signals. So these are the three important conclusions we have to draw. So before concluding, one remark statement I want to put, which is a very important statement. For every energy and power signals, we have to make use of this formula. Energy is equal to power into time. And for example, let's say power of a signal is finite. Let's say power is finite. But if we are computing power for infinite duration time signal, then energy will become infinite. So if power is finite, if power is finite, but its energy is infinite, okay, then it is a power signal. And if energy is finite, if its energy is finite but its power is zero, then that signal is energy signal. So we have to remember these important corollaries and important relations which are very important while solving the problems. So with this, I will stop here. Please do like my videos and subscribe my channel. Your comments are important. Please write your comments and suggestions and ask any difficulties in the comment box. Thank you very much.